Welcome back, everybody. We're back from a 1 week break, and we're going to pick up our slideshow where we left off last week. We got about halfway through this Unit 1 material. I do plan on getting through the rest of it. I am going to actually go into slideshow mode here, and I'm hoping, and of course, it starts in a spot where I don't want it to. Thank you, PowerPoint. Let's try that again. Slide 67. Great way to start a video on YouTube, by the way. Where it's all smooth, and of course now I'm looking at Unit 2. All right, let's try that one more time. It's fun to watch your instructor fumble with his PowerPoints. Maybe I closed it. All right, let's slide 67 is where we're starting, and I don't know if this is going to give me the split screen view here. Apparently not. But we had covered like the first two topic areas, and we're now going to complete the topics that are left in this unit. And one of them is how AI works. And one of the reasons I'm going into the slideshow mode here, real frankly, is because they do have these little slide overlays and animations that they throw in to kind of make it look a little bit cooler. But what I have up on the screen right now is a graphic or a listing in a hierarchical form of different types of AI models, all of which are based on machine learning algorithms and neural network patterns. And if you did a super deep dive on this technology and became an expert in it, you would recognize most of these things. Okay, so okay, don't go into panic mode. We're not covering all this stuff in this course, right? We're gonna brush upon some of the key ones, but I do want you to kind of notice though that at the core are the machine learning algorithms. So where you really start to get into like the mechanics and the math and the logic aspects of building this stuff, it comes in that course, right? The process of how they got from taking mathematics and basic programming and turning it into these technologies is a traceable pattern, right? It doesn't appear from nowhere. I think it's also kind of interesting that as you guys, many of you are currently studying statistics this semester, or maybe you've done it in previous coursework, you'll notice that a lot of the stuff that drives this is based upon statistics, and often what area of math we call set theory and logic. So for example, when you talk about Bayes, that comes from stats, right? And when you're doing stats, you'll learn about Bayes' theorem, right? And etc. Now I'm going to go ahead and advance the slides here, and you'll notice a couple of like really key areas that they're going to highlight. For example, decision trees, right? And there's a whole bunch of different types of decision trees, all with their own mathematical logic and formula behind them. The people that are in my data analytics class, where we're working on spreadsheet stuff right now, learning the basics. But when you get to really high level spreadsheet stuff, you do some of these decision tree things in spreadsheets with formulas, believe it or not. So pretty fascinating. There's also what we call linear regressions. This is a really common aspect of statistics too, where you correlate values together. So for example, if you have more income, you tend to live in a nicer house, that kind of thing. That's like a linear regression. Those are all built on mathematical formulas. Or maybe you'll hear about this in your stats class too, like what we call the K nearest neighbor, or the KNN, where you're looking for information that's closest to the stuff that we're looking at. There's also the random forest. These are all like really weird words. Like we're throwing them out and you're like, oh my God, what does this stuff mean? Don't worry about what it means right now. Laura, I see your hand up.
Oh, Noah said he can't see the slideshow in the chat.
Yeah. Did you already pull it up? It
Yeah,
should
it's
be in
up on the
slideshow mode.
screen.
Yeah, I just see your face for some reason. It must be one of my settings.
Uh,
Can
I
everyone
had to
else
turn
see
off
it?
my camera because it
Oh,
was
okay.
freezing.
The view box on top.
Okay.
Okay.
That could be, yeah. Um, you know, interestingly, one of my other classes, and this is at a different school, I published a video with them from last week. And sometimes I do this task switcher thing where you see this, right? And apparently that got stuck on the screen for most of the video. Thank God I had backup videos from last year. But yeah, not good. So if you guys see any weird like output like that, please let me know. Um, so hopefully not. All right, I'm gonna click forward on this. Gotta make sure I'm on the slide here. So another one that we'll look at is just real briefly as an example is this one called perceptron, which is part of the neural network branch of machine learning and part of the area that drives AI and how AI works. And we're going to look at one of its most fundamental structures, right? So once again, please don't freak out to any of the math or the symbology here. Usually when we're dealing with math on this level, the nomenclature or the terminology we use is based on calculus, right? So usually you don't see a sigma or formulas with sub numbers that are all variable based until you get to calculus. The one thing I tell you is don't freak out ever to a formula. Formulas just try to explain things that we're doing in the real world. And when we start going forward on this stuff and actually working with the real formulas, everything will be explained and there's a pattern to it. There's a methodology to it. It's all learnable, right? And it's not like a mysterious thing. It's just a process you have to follow. Now, when you're doing this approach that they call a perceptron, they use a bunch of different inputs, right? So you're going to see a bunch of inputs will be coming in, and they try to address all the different possible scenarios that they can think of. And then we place weights upon those scenarios. So in other words, in certain scenarios, certain things will be more important than other things, so we basically score them so we know what's more important, right? And that will have a greater multiplier. We then take the weights and we basically multiply and add the weighted sum to figure out where we're at, and then we come up with a result, which usually, and they're going to specify here, is basically going to give you an output that will determine which course of action you're going to take. And this is how AI works mathematically in the background, at least with this algorithm, right? This aspect of it. So basically what you do is you take all your inputs and you add them all together, right? Whatever those factors and conditions are. Now the inputs could be very simple pieces of information, or they could be complicated formulas in and of themselves. It just kind of depends on the scenario. They then take those inputs and we weight them. So at this level of the process, we give them values. So like maybe this one is more important than that one. So it has a greater multiplier attached to it. And then ultimately that, there's sometimes what we call a bias added to these things. So for example, because we'll talk about autonomous vehicles later, like if there's a self-driving car and the car's it's going to be unavoidable, it's going to be in an accident, and the choice is smash into a tree or smash into a person, which one does it choose? Right? Hopefully we program that vehicle to smash into the tree. It's better than killing a person, although smashing into a tree might kill a person also, right? Or maybe you can really complicate it and say you kill the young mother and her child, or you kill the two old people crossing the street, and it'll probably pick the two old people. Let's get rid of those old people. Boomers be gone, that kind of thing. I am joking, but that is the kind of stuff you got to program that stuff in. One of the examples in the videos I have in the next chapter's PowerPoints shows a simulated accident, for an autonomous vehicle. And it's kind of like, oh, wow, what are you going to do? Yeah, I don't know. It's a good question. All right. So you introduce a bias, sometimes it's like, okay, it's better to kill the old people than it is the young children, I suppose. And that's all kind of built into these formulas. Is this repeating? It seems to me like it's repeating. Okay. But then ultimately, the result of this whole matrix is either a positive number or a negative number, and that will determine um, whether you had a good outcome or a bad outcome. So in other words, and we're going to apply this to kind of like a real world scenario here, so you kind of get the point of what I mean. So you might need to decide, okay, hey, I like to go to the park, right? So how do I know if I should go to the park today or not? Okay, well, you ask these questions. It's like, um, do I have a coat? Do I have an umbrella? Is it going to rain? What's the forecast, right? Like maybe not in that order, right? But those are kind of the kind of questions that you ask. How do you make the decision on that? Well, you got to figure out how you're going to make the decision on that before you're going to tell an AI how to make a decision on it. See the conundrum here. So first, look out the window. Is it raining? Maybe, maybe not. I don't know. And then, you know what? We all have phones now, right? We just look at the forecast. Hey, look, it's going to be 72 and sunny. Perfect. I'll go to the park. So then you know what the forecast is later, because it might be sunny now, but it might storm in an hour, right? Then you might ask yourself, well, if it's going to storm in an hour, do I have a jacket to bring with me? Bring my windbreaker or, a hoodie or something. And then finally, do I bring an umbrella? What's the likelihood of rain? So, we have to consider all of those things. So using the perceptron approach, right, we set up inputs, and I want you to notice the ones and the zeros before the inputs, right? So for example, do I have a jacket? The one is, yes, I have a jacket. Do I have an umbrella? No, I don't have an umbrella. Is it sunny now? Yes. What's the weather forecast for later? Meaning, is it going to rain? And that's got a zero. So I'm probably going to be okay with the jacket if it's sunny. Right? You see the approach here. Then we also throw weights. Like what is like, what has most value here, right? Well, if it's sunny, that's got a high value. And if it's sunny, of course, it's not raining. So that has more weight in the output. Where if potentially it's going to change later, that also has a pretty significant weight. So it might be sunny now, but it could storm later, right? This is like the classic situation you have, like you go to Summerfest, right? It's like, do I bring a jacket? Do I bring an umbrella? And then of course, when you don't, that's when it rains and that's when it gets cold, etc. Then you also have this bias piece, and this kind of sits as a tangential input, right? Which might skew you to one direction or the other. We'll look at what bias means particularly. They're not really specifying here, but ultimately this all kind of converts to formulas, and the formulas are pretty simple. So the stuff that aren't part of the formula, the zeros here, will multiply out. They just drop out, right? Because I don't have an umbrella, so it's not relevant, and it's not going to rain, so that's not relevant. So then I multiply through the other stuff, and I get an output, and that works out to be a positive number. So that means I'm going to the park. That's how this algorithm works, right? So once again, not anything you need to memorize at this point, but those are the kind of formulas that we get into when we start to do machine learning. And we actually apply mathematics to it. So like if you're building an AI, you've got to write these algorithms, and they're not built on nothing. They are built on tangible mathematical formulas and processes that have been around for a long time. So we're going to move forward now and talk a little bit more about, this automation versus AI thing, and define technically what automation is, how it's different than AI, and benefits, and then of course a little discussion, but I'm probably going to gloss over the discussion. I'm just going to let you know that, right? See, this is one of the reasons I'm doing the slideshow, like the little animation here. I'm not sure if it's traveling over the internet really well. But the point is to kind of show this thing, and this has been happening for a long time, actually, if you think about it. We had the Industrial Revolution starting in the mid 1800s. By the time we got to the early 1900s, we had, factory production lines, like basically instead of like things being built onesie twosie, we had mass production and we had systems where we had conveyor belts and a process that stuff would go through. So like here it says automation means designing software or hardware which is capable of automatically doing things without any form of human intervention. This is not AI though. That's like I have a machine, and some of you might even work in places where there's machines like this, right? Um, Heck, even Burger King's got automation on their burgers, right? They throw them on a conveyor belt and it goes through, or it used to be that way. And they have it all timed out. You just put the burger on the thing, it comes through out the other side. It's perfectly cooked. Nobody had to flip it or anything, right? It's like golden brown, delicious, and flame broiled. And little did you know they add the smoke flavor. But, regardless, there's a kind of an automated process, right? Um, no humans are needed. Well, I guess the humans got to put it on the thing and the humans got to pull it off. Or is that automated now too? I'm not really sure. So automation has been around for a bit. In many cases, automation is working side by side with human beings in many environments. And I think the Burger King example is probably kind of a good one, right? All right. So I want you to notice, and this is kind of a neat little graphic, and I did not mean, right? So I'm not in editing mode. I was going to make it bigger. Duh. Okay, I can't do that. But if you look at that graphic at the bottom, here's a production line, probably in the Ford plant back in the 1920s, and they have a bunch of vehicles moving down a line. And if it's your job, and a lot of production lines still work this way, there's human beings that perform repetitive tasks building those vehicles. Like one guy's job is maybe just putting a tire on, and he always does the front driver's side tire every time. That's what he does all day long. you know. Now, modern car factories like the image that we see above, lots and lots of robots. Why? Well, all the bullet points, right? They're faster. They run 24/7. They don't ask for vacations. They don't ask for a pay raise. They don't get sick, etc. And honestly, if the company's saving money and the product comes out cheaper, doesn't that benefit you, the consumer? Well, not if you don't have a job to pay for it, right? So what job should you undertake if those cars are being built by robots? You should be the robot programmer, the robot technician, etc. Right? There's still probably human beings in the process there somewhere, but it's hard not to take advantage of those. I think this chart is very, very helpful in terms of defining kind of the definition. So if you guys will begrudge me like reading a little bit of this to you. So if we define automation, it's hardware or software capable of automatically doing things without any form of human intervention. We just saw that, right? AI is a science as well as engineering, which is involved in making machines which are intelligent. Okay, so very different defined, right? The data. Okay, so what's the role of the data in this? In automation, all the types of automation which are bound using explicit programming rules. So there's no real usage of data. So in other words, automation, it's just set to do the thing that it does. And the data that I feed it, it's not going to change it. I got to change the program that's running it or the machine that's running it, right? The data will not impact it. AI, on the other hand, needs large, in fact, huge quantities of data to feed in information. It uses neural networks, graphs, machine learning, etc., to dynamically adjust to the situation based on the data. Right, so very different approach. So automation is good for repetitive tasks, frees up valuable time. Great, right? AI is designed to seek patterns and learn from experience like people do, right? So it can self-select the appropriate responses according to the situations. So in other words, if we train something with AI and it's using AI to run it, if something, the guy needs to put the wheel on, but the axle's not there, the AI would be smart enough to not put the wheel on where the automation would still put the wheel on. That's the difference, right? So one's basically just a machine. The other one has some level of knowing and intelligence behind it and is self-driving, basically. Um, let's let you read that for yourself. All right. Now, this is kind of interesting because now we're starting to throw the concept of generative AI into the mix here, because the Gen AI, of course, allows us to not just do stuff with intelligence, it allows us to create stuff, right? One thing you guys will notice is that as I'm starting to put some of the new homework assignments, I'm going to start to encourage you to use generative AI to help you do your research, right? So instead of like having your teacher say, "Don't use AI," I'm going to do the opposite. I'm going to encourage you to use it as a tool, but mostly for research, not necessarily generate your papers. Um, so it says here traditional AI systems follow established rules and patterns, right? So in other words, there's also a distinction within AI here. So I can program an AI to, make these decisions in these situations and to learn from that and select which is the right course of action. But Gen AI lets us feed data and allows it to dynamically create its own solution, which is more like what a human does. And this is the cool thing and also the thing that kind of terrifies us at the same time, right? So here's some questions you guys can like just take these as fuel for thought. We're not going to spend time talking about them. Um, you know, are AI and automation working together? The answer is already yes. Those are happening together, but not as much as you might think. So we see robots in a factory and we're starting to think, oh no, Skynet is here. Not really, right? Those are still basically dumb machines. They're waiting for our instruction. When we start to program that robot where it can make its own decisions, or maybe it realizes, hey, widget A is breaking down. I better shut myself off because I'm going to have a catastrophic failure intelligently. Or is it being intelligent, or is it just well written software? So I asked that question. Noah, you got a hand up there?
Curious, are your colleagues using AI themselves, or are they still a little off to it and like don't want people using it?
In terms of colleagues, are you talking about my fellow instructors here at Gateway?
Yeah, fellow instructors, people who aren't in the AI field, I'm sure the people that are in AI love it, but like teachers in statistics and stuff like that, English.
Yeah, there's a lot of instructors here, especially in the traditional disciplines, that are terrified because um, Gen AI is hitting like English classes harder than it's hitting programming classes. Um, my IT instructors, there's divides among us too, because in some cases, AI is creeping into everything, but in some cases, it's not necessarily directly applicable to the stuff that we're doing, but it is becoming more so all the time. It's hard to avoid, and I think there's a pool of us, and I don't need to name any of them. I think you probably know who they are. Probably most of the ones you guys will encounter that are pretty embracing of it. Um, Both as a tool and as a work accelerator, and that, I think that's you know pretty interesting in and of itself. All right, let's kind of move forward here. We did talk about some of this stuff last time, and I think we may have even looked at this graphic or similar graphic. You know, here's a lot of the usages that we're seeing for Gen AI right now. And you can just read through the slide on your own. So like you can break it down by category. You will notice that um, text, code, images, huge usage there, right? So pretty scary stuff, when you look at like, or you consider that you could like, for example, take an image of a person, or the AI can just find one and tell it to generate an image that makes it look like this person is doing some action that they're not really doing, and you put it out there and it looks pretty darn real. How do you differentiate reality from not? um, I think we mentioned this last time, like you can watch a lot of um, television shows these days where they have like these grand sweeping landscapes, or like Oh my God, that's pretty amazing. They really hired like 1 million people to sit out in the field and fill them in battle. And it's like, no, 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 that's all CGI AI generated, algorithms, right? And that's been going on for a really long time. It's not even you, you know. I think the more interesting thing is to spot it as when you're looking for it. It's like that's not real, right? I think one of the, like I think we talked about this too. Like, I look at the far right column where we have it infiltrating a lot of creative arts right now, where, like, for example, you'll go out on Spotify and you'll fire up your jazz list so you can study because you want like music with no words on it. And then every other song that's played is something that was generated by an AI for Spotify, and Spotify reaps the royalties off of it. You don't even know because you're not really listening, but you're letting it roll and you're paying your subscription fee, right? So very, very interesting world we're stepping into. Now, a lot of this takes significant computational power. And I think that um, if you, and I think most of you, or a good portion of you, have either taken the Python class with me or possibly with Christopher or Christian. And if you take it with me, I do a whole little spiel on computer history. I don't know if you guys remember this, but we talk about like ENIAC and how ENIAC started with vacuum tubes, right? That was the fundamental electronic component. And then vacuum tubes, which are akin to light bulbs, basically. They have like inert gas in them and they light up and they take a lot of power and they don't do a lot for their size. And then we transitioned over to transistors, which are tiny little things. And then they figured out, well, I can take these transistors and we can put them on these little silicon chips. And that's where we are now, is we're in this era of the integrated circuit, right? And we have been here for quite a while now, since basically the early 60s. So integrated chips are basically a technology that is built on a transistor as a fundamental component. When we take multiple transistors and we put them on one device, we call that an integrated circuit or integrated chip, right? Um, when we take the modern CPUs that we have now, and this is actually, like on my screen, that's probably close to life size, what a CPU looks like. But if you could tear apart your computer and find the Intel chip or the AMD chip that's powering your system, it'll sit on a little square that's, maybe, I don't know, 1.5 inches, 2 inches square. But the actual chip itself is the little metal thing in the middle of it. So it's not even, I mean, we're talking like a 1/2 inch across, you know. This little thing has, these days, and somebody could Google this really quick or ask the AI, how many transistors are on a modern, like 10th gen Intel i7 or i9? How many transistors? See who comes back with the answer on that one.
It says 1.25 billion transistors
One
on
point,
a 10th generation Intel i9.
okay, 1.2 billion, billions and billions. So billions of transistors. And then when you start to think about how small that is, I can't even like imagine how small that is. And they got 1 billion transistors on there. No wonder we're having a revolution, right? I mean, that's insane. But back in the 60s, when they first started doing integrated circuits, um, they would get, if they were lucky, somewhere between 1 to 10 transistors on one single integrated circuit, right? Um, and then they just started scaling up. By the time they got to the late 70s, they were getting hundreds. And then by the 70s, where we started to see like our more modern CPUs, thousands. And then just by the early 80s, we're looking at, what is that, 1 million or more transistors on a chip. And 1984 is kind of like one of those eras. This is always kind of interesting too. Like in 1984, Apple released the first Macintosh, which was the first 32-bit computer processor. And IBM and most of the other computer manufacturers that were making like these consumer level machines were still working with 8-bit processors, right? That were like 1/4 as capable. And I think that's kind of the era. Now you can just imagine, you see the numeric rate of increase here? That hasn't slowed down. They're developed exponentially larger chip. It's insane, the rate of development. Then they started hitting some theoretical limits on the chip architectures, um, where it's like, okay, well, we've reached all we can do on one chip. I know, let's have multiple cores, right? So you get these CPUs that have multiple cores now. So instead of having one CPU core, you might have like 6 or 8, and if you have some of these new Apple machines where they have like, you know, I don't know, 8 or I think 8 CPU cores, 8 GPU cores, and 12 machine learning cores all on the same chip. Like, oh my God, right? It's like, we were having this weird discussion with a friend about a week ago, total nerdy guy, and we laughed because everybody's got like these very sophisticated smartphones now. That one of our smartphones, any one of ours, even the junkiest one, which is probably mine, right? I have like a Samsung S9 still, because it keeps working, um, has more computing power than all the computers on the planet when we put men on the moon, in my pocket. And what am I doing with it? You know, TikTok, playing video game, watching dumb video, whatever, right? I mean, and holy cow, it's like this is like mind-blowing science fiction kind of stuff. So we went from like not having any technology basically, you know, to having supercomputers in our pocket. And wow, all right. So the the whole rate of increase of production of these chips has really driven AI development too. Very interestingly, one of the people behind a lot of the chip development that drives AI, if you guys are familiar with NVIDIA, they're a graphics card company, and a lot of us, even I have an NVIDIA graphics card in this machine here. The guy that started that company was a student at or MSOE in Milwaukee School of Engineering, and he's actually donated a huge supercomputer based on those chips for the school. But they just came out with their latest processors, right? And there's people already lining up to buy them. The graphics processors tend to run at higher processing rates than the regular CPUs do, and are often used to do AI work, by the way. Right? So more processing power, more speed. There's all sorts of different types of or hardware accelerators, and you can see the GPUs that I was just talking about is that way at the bottom of that list. But it's not the only type. So there's different types of basically CPUs and chips that people put together for specialty purposes. And the ones that are most used for AI tend to be the ones at the bottom of the list, by the way. In fact, there's entire libraries for like TensorFlow and stuff like that. But GPUs are used very much for doing AI work, which is one of the reasons why the price is so high when the new one comes out, because a lot of companies are racing to buy those new chips to put in their AI systems, right? And oh my God, the fact that once again here we have a Wisconsin connection, to this amazing technology is pretty cool. So lots of stuff that we do with AI, and we're going to talk about this as we go into the next unit. Like what fields of work do we use this in? So we use it a lot in all of these areas. As you guys were watching like the football games that were happening, I don't know if you guys are into playoff football or not, but they like always show all this like data analytics stuff, like Amazon powered, or they have like AI that like determines the probability that they're going to succeed on 4th down, when they're going for it, like really crazy stuff like that. So it's infiltrating every area, but there are these big sectors in our economy that are starting to lean on this stuff for really good reasons, because if they can improve productivity, lower costs, et cetera, et cetera, et cetera, I mean, they're going to do it. right? It's all about efficiency in these industries. And they'll infiltrate just about everywhere. A lot of the stuff that happens with, why it's pushing so quickly, and it's not just AI, because keep in mind, the concept of AI has been around for a while. We're just finally getting to the point where we have the computing power to really pull it off. But there's also these other technologies that are coming into the mix, and we call these disruptive technologies because they're so radically improved over what came before that it's changing the way society operates. Now, when you take these things and you combine them with AI, so we're talking about the 5G, okay, so like increased wireless bandwidth. Um, I don't know how many of you are on 5G. I assume most of you. My phone's still on 4G, because it's an old one, so I don't leverage that. But 5G is a very different kind of way to do cell phones. Instead of using one big tower, they use lots of little ones. I don't know if you guys are aware of that. Um, and the bandwidth potential is significantly larger. Autonomous vehicles, that revolution is also happening right here in our own backyard, by the way. The Internet of Things, and this is like small, usually sensor-driven devices connected to things that create big data feeds and do specific tasks. And then we have just a huge volume of data, in dealing with big data and how we organize it, store it, retrieve it, query it, all that stuff. And these have already like started, these disruptive technologies, all of them are already happening, right? No wonder AI is just exploding. So some of it, we have to start thinking about this instead of being terrified by it. And obviously you guys are, I'm assuming, embracers, because you're here to learn about it. Is instead of thinking that these machines are going to put us out of work, we need to start thinking about this thing that they're our partners. They're going to help us, right? And there's nothing to be afraid of, you know. So let's not think of it as like, hey, the robots are coming, I lost my job, and now I'm angry. You don't want to go there. Now you just have to leverage it to your advantage. Um, the the part that obviously scares us most is the second bullet there, that uh, if they get creative and they get an emotional intelligence on top of it, uh-oh, right? Now the robots have feelings. Now we got to watch what we say too, right? You made robot angry, right? For sure. All right. So I think that, as we move forward, and this is going to be way more of a thing for you young people here in the session, where are you going to put your energies for the future? What are you going to study that really makes sense? I mean, I think it's a no-brainer, right? I mean, it's here, it's happening right now. Anybody that's already doing it is wise, right? You're preparing for a future. I think, and I'll probably repeat this countless times in these classes, is, you know, you think it's late to get in the IT game. It's not. I think we're at the precipice of a radical change in society in like the next 5 to 10 years. It hasn't hit quite yet. It's just starting. But when it hits, it's going to be completely transformative. It's going to be a different world, folks. And there's also going to be a big digital divide too, because there's going to be plenty of places on the planet that aren't there yet, right? And that will be weird. They're also kind of pushing here to maybe throw some new words in there. Cobot, so collaborative robotic teams. You might already work in environments with this. Like if you work at like one of the Amazon distribution facilities, they have lots of robots that fly around those places, picking and moving packages around. Are they your competitors or are they working with you? Well, kind of a little bit of both, I suppose. We have a lot going on in terms of we've got more data to contend with. We're generating it. We have to process it. We also have the cost of hardware coming down rapidly, right? And the little chart there, like in 1995, it cost $1,000 for a gigabyte of storage, right? If you wanted a 1 gigabyte hard drive, it cost you $1,000 back then, right? And in 2020, it cost you 2 cents. So it's like Okay, yeah, prices come down. We also have algorithms. So like a lot of these basic AI algorithms, like that big page of like things that we were looking at, some of them have been around for a while. Like the logic behind them has been around, but now we're coming up with better models. And then, hey, now we can throw a generative AI to work on the models too to make them even better. Okay, scary stuff, right? So the rate of improvement and just the way we're developing it is increasing uh, exponentially. We're not going to do this task, by the way, but we are basically done with the first unit. Um, Here's some questions you might want to ask yourself. You know, I think you know the answers to these. Uh, but yeah, we're moving forward, folks. Um, I also want to remind you that all of these slideshows, this one doesn't have that many, but I like unit two's got like 5 pages of bibliography, including like video links and whatever. So if you guys want to like deep dive on this stuff and really go to the source materials, they show them here. Right? I do look at a lot of the content and go, some of this is already dated, so like you can only imagine that there's more content up there. This video will end